understand the basics of electricity. Okay. So what? To understand electricity, we need to understand what is a charge. Okay, what is charge? Okay, what is the basic unit of charge? Okay, and all that. The basics we'll have to start from. Okay. Tell me what is the charge on an electron?
A charge is like the charge on an electron is negative.
Yes, the charge on an electron is negative. Okay, proton is positive. Okay, neutron is
Neutral.
neutral. Yes. So what happens when these charges flow? Okay, when these charges flow, it creates
Yeah.
electricity. Yes. When these charges flow, it creates electricity. So electricity can be defined as rate of flow of charge. Okay,
Okay.
rate of flow of charge. You can define electricity as
All right. Yeah, it's the rate of flow of charge. Yeah.
yes. So we usually express it with the symbol I. Okay. So you can either write Q by T.
Yeah,
Okay.
Q is equal to
If,
I T. Yeah.
yes. If Q amount of charge passes in T seconds, we can calculate the current flowing across a certain cross-sectional area. We can say this much current, okay, is passing through it. Okay. Or in differentiation, tell me what can I write?
Pardon?
With respect to differentiation, dq
Uh,
by
sure.
dt. Do you have? Okay. I hope you have this in your syllabus, right?
I don't know. I haven't started yet. I start in September.
You started
I start in September.
September. Okay, no problem. Okay. So I is dq by dt. Okay. In short, you don't have to focus on this as of now. You just focus on this right now.
Yeah, Q
I
is
is
equal
equal
to
to,
IT.
yes, and q is equal to it. Correct. So if you send this on the right side, you will get charge. If you have to find out, this charge is nothing but I cross T.
Okay.
Okay. Now let's talk about a little bit of units. So the unit for this is coulomb. Okay. The unit for this is coulomb. I think yeah, correct spelling, I think it is. So the unit of charge is coulomb. For
Yeah.
example, how much charge is there on a charge or on an atom ion? Okay, we call it has 5 coulomb charge. It has 9 coulomb charge. Okay. So
Okay.
like that, the unit of current is
Mm-hmm.
ampere.
Okay.
The unit of current is ampere. It is denoted by A, and coulomb is denoted by C.
Coulomb is divided by C, ampere A, and then time, which is
Time is, yes, in seconds, right? This is pretty simple. Time is denoted in seconds. So it is important to know the units also. Okay. So 1 ampere can be written as 1 coulomb per second.
yeah.
Okay. Ampere is nothing but 1 coulomb per second. Now you can write this as either coulomb per second like this or like this also. Okay.
Yeah.
This is just a way of representing.
Mm-hmm.
Okay. But I would suggest you to choose this way of writing. Okay. This is more generally accepted now. So 1 coulomb per second. Okay. Now let's see what other topic is there in your syllabus so that we do not uh, discuss higher level topics. Let me just take a look.
Mm-hmm.
Okay. So in which country are you right now?
England.
Okay. One second. Okay, so we will cover the basics of, okay, before we understand this, okay, you need to understand a little bit about vectors. We will understand about resistance. Okay, we understand
So
resistance. Yes. What is resistance?
resistance is like the amount of is the rate that it's able to essentially slow down the flow of charge,
Yes, correct. Okay.
and it's
The
measured in ohms.
yes, correct. It is measured in ohms. Okay. So this is nothing but a measure of how much resistance the flow experiences. Okay. For example, you can imagine yourself, you are running in a crowded place. Okay. So you will be experiencing a lot of resistance. Okay.
Mm-hmm.
You will be experiencing a lot of obstacles on the way. Okay. You may get pushed by someone. Okay. You may collide into
Yeah.
somebody. So all that comes into the concept of resistance. Okay.
Mm-hmm.
So how do you define resistance? What is the formula for it?
What? So V is equal to IR.
Yes, B is equal to IR. Okay. So that is basically, you'll understand that also, or you can rearrange the terms like this also.
I just remembered the what's it called the because we have like a formula sheet, so I've learned them the way that they are on the formula sheet.
Yeah, yes. You can learn according to that also. V is equal to IR. Whatever feels comfortable to you, both are essentially the same formula. Okay.
Mm-hmm.
V is equal to IR. Okay. So according to uh, uh, Ohm's law, right? This is the Ohm's law. V is equal to IR. Okay. So if you want to represent it like this, you can write it like this, or you can rearrange the terms to get the resistance also. Whatever feels convenient to you, you should do according to that.
Yeah,
Okay.
V is equal to IR because that's how I've remembered it since like the year nine.
Yes. In the year nine, where do you start in year nine? You start by saying that the potential difference is proportional to the
Yeah.
amount of current flowing across it. Okay. The first statement is amount of potential difference is proportional. Okay. So if the potential difference is high, the current will also be high. Okay.
Yeah.
And if the potential difference drops, the current will also drop. So
Mhm.
then you introduce a constant. Okay. Whenever you replace the sign of proportionality, you introduce a constant, and that constant is nothing but R. Okay.
Yeah.
So R becomes your resistance. Understood?
Mhm.
Then you'll understand the basics of adding resistors in series. Okay, in series or parallel. Okay,
Yeah,
you
I
have,
got that. I can just like tell you what they are real quick. All right. So for series, yeah, it's like the
yes.
cut in series in a series circuit. The what's it called?
What is the
I know in
equivalent?
a parallel circuit, the current splits off at each branch, and the potential difference remains the same in parallel. So in
Yes,
series, it's the opposite. The current will change. The current is for each component, and the voltage is the same.
yes. What happens in parallel? The potential difference remains the same. Okay, so for example, if this is 15 volts here, so the potential difference here remains 15 volt. Okay, the potential difference remains here 15 volts, but the current splits up. Okay,
Yes.
this I this I splits up into two parts. You can call it like I1, I2. Okay, and then you can write I is equal to